So chapter 12, exercise 9 gives you a couple different compounds, and it asks you which one is more soluble in water. Now, one thing you really want to know, that you want to take with you through life, is that the rule for solubility is like dissolves like. And what that means is that a polar solute dissolves in a polar solvent, and a nonpolar solute dissolves in a nonpolar solvent. Remember what it means to have a pole. If I draw any molecule, the way that you can recognize whether it's polar or not is whether there's a big difference in electronegativity. Electronegativity on the periodic table increases as you go up and to the right. So the most electronegative elements are here at the top right. Electronegativity tells you how much an electron is attracted to a nucleus. So for example, let's say you had oxygen and hydrogen. Oxygen is in this top right region, so it's really electronegative. Electrons find oxygen very attractive. Hydrogen is far away from that. It's on the other side, and so it's not as electronegative. Electrons don't find it as attractive. So if you're an electron in this bond between the two, you're going to be much more attracted to oxygen, and you're going to spend more time around it. And you still will be a little attracted to the hydrogen. It does have a proton, but you're not going to be as attracted to it. And so the oxygen will become slightly negative, and the hydrogen will be slightly positive. The oxygen's becoming slightly negative because the electron, which has a negative charge, is spending more time around it, and the hydrogen is becoming slightly positive because it is less electronegative. The electron is spending less time around it, and the electron has a negative charge. So that is what's called a dipole. This bond has two ends. Pole. The word pole is another word for end. For example, the North and South Pole are the two ends of the Earth. So it has two ends, a positive end and a negative end. And any bond that creates a separation of charge like that, and so has two ends, is called a polar bond. Now that happens when you have really electronegative elements. And so if you ever have nitrogen, oxygen, or fluorine, those are those elements in the top right there. Some people also include chlorine sometimes, but especially nitrogen, oxygen, or fluorine, you know that that bond is going to be polar. Now water has these partial charges, as we can see, so water is very, very clearly polar. So I'm going to write that here, water is very polar. Let's do this. Polar. Okay. So in this one, they're asking which compound would be more soluble in water. Well, that's going to be the compound that's more polar, because a polar solute dissolves in a polar solvent. Like dissolves like. All right. Well, let's look at each of these molecules and see which one is more polar. I'm going to circle the polar parts with a yellow, and then I'll circle the nonpolar parts with green. Here, we know that this is polar. The rest of the molecule is nonpolar. That's in the first molecule. Remember, big differences in electronegativity make a bond polar. The most electronegative elements are nitrogen, oxygen, and fluorine. They are in a different league than other elements. They attract electrons to themselves, sort of steal the electrons from other elements, and create polar bonds. In the second molecule, this bond is polar and this bond is polar, whereas a smaller portion of the molecule is nonpolar. So which of these is more polar? Which of these molecules is more polar? The second one. The second molecule is more polar because it has 2 bonds that are polar, whereas the first only has 1. And water is polar, and like dissolves like. So these are the three sort of steps you want to put in your explanation, which is the most important part of this. You'd say the second, so first write your conclusion. The second molecule would be more soluble in water. And I would make sure that you circle it also, so it's really, really clear. The second molecule would be more soluble in water because, 1, it has more polar bonds. 2, water is polar. And 3, like dissolves like. So that would be the explanation for why that second molecule is more soluble in water. Let's do the same thing here, except here we have to draw the molecules. Now acetone is a common name. It's the name for propanone. Propanone is when you have 3 carbons, double bond to oxygen. You can see from the ending "-one" that it's a ketone. It has a carbon double bonded to oxygen with a carbon on both sides. So that's acetone. 2-pentanone, let's draw that one. Pent means you have 5 carbons, so I'm going to draw a dot. 1, 2, 3, 4, 5. AN is telling you have all single bonds between those. ONE is telling you have a ketone, and that will be attached to carbon number 2. So counting from the end, that would be right here. So that's 2-pentanone. Now, I'm going to circle the parts that are polar. Those are the bonds and the atoms in them that are connected to oxygen, nitrogen, oxygen, or fluorine, the most electronegative elements. So this is a polar bond, and this is a polar bond. I'm also going to circle the parts that are nonpolar. So here, this is nonpolar. These are nonpolar. Okay. Notice that they're both equally polar. They both only have 1 bond that's circled in yellow. But the molecule on the right has more nonpolar parts. Oops. Nonpolar. Right? And so, this one on the left, if the one on the right is more nonpolar, the one on the left is more polar. Not because it has more polar bonds, but because it has fewer nonpolar bonds. So you would choose your molecule. You'd say the molecule on the left would be more soluble in water because, 1, it has fewer non-polar bonds. It is more polar. 2, water is polar. And 3, like dissolves like. Okay. Same question. Which of these would be more soluble in water, propanal or pentanal? So let's draw these out first. The first one has prop. That means we're going to have 3 carbons. So 1, 2, 3. And the infix is AN, so all single bonds. The suffix is AL. That means on the first carbon, we're going to have a double bond to oxygen, single bond to hydrogen. That's the suffix for an aldehyde. We do the same thing. Pent means 5 carbons, so we've got 1, 2, 3, 4, 5. The infix is AN, so all single bonds between those. The suffix is Al, so again, we have that double bond to oxygen, single bond to hydrogen on the first carbon. So there's propanal and pentanol. Now I'm going to circle all the bonds that include nitrogen, oxygen, or fluorine. Those are the polar bonds. So that's this one and this one. Then I'm going to circle all the nonpolar parts. Here's the nonpolar, here's the nonpolar part. Notice that the one on the right has more nonpolar bonds. The green part is bigger. The one on the left, then, would be more polar. And it would be the one that would dissolve in polar water. So you'd say the molecule on the left is would be more soluble. So would be more soluble in water because 1, it has fewer nonpolar bonds, so it's more polar. Water is polar, and like dissolves like. You want to make sure your explanation included all 3 of those things.